Morning again, guys. This is going to be a short and sweet tutorial about how to performance test, perf test, a component of your Scala Play app. In the last video that you should probably watch if you don't already have some kind of job runner set up for your Scala Play app, we went over how to create a job runner. The link to that is below. It's a pretty quick tutorial. I think probably you only need to watch the first 10 minutes or so to set up a job runner, maybe less. And in that job runner, you're going to be able to run whatever you want with the context of the Scala Play application. So for instance, I can go get, for this course app that we're creating here that lets you view professor reviews and like see all the courses. So we can just type in a course here and it takes us to that course and we can see the prerequisite trees. I can go and call instances of my services. I can get those from the injector of the Scala Play app, which is really cool. And now what I want to do is fine-tune my database queries so that when I'm fetching courses, they're efficient and as efficient as possible. So how we do that is pretty simply, we create a test here. So I've created this test, and it's an exaggerated test, but what it does is it goes and it grabs all the courses in shorthand form, and then it just fetches those 5 times. It fetches all of them 5 times and concatenates that into a large array from our Mongo or reactive Mongo database using this course repo. So what I've done is I've taken something reasonable that we do, which we've run this course repo find courses in the app in several places, and it's fast by itself, but it was being run a lot of times. What I want to show is that it could slow down our database or cost us money or something like that to run a bigger database. So what I'm doing here is I'm going into Mongo and querying 5 times all the courses, and I log the start time here at the beginning, and you log the end time after all these courses have been pulled, and then just to make sure the job is deterministic so that it simulates the same requests every time. What I've done is logged out the size of all the courses that it got. So this would be it should be 5 times however many courses are in the database. And then also you log out the difference in time between the end time and the start time, so you can see how long it took. And it should be fairly reproducible, ideally, for most things, unless you're dealing with network I/O to a third-party vendor. You want to performance test things that you can change. So I'm going to go ahead and really quick explain line by line what's going on, and then we'll run this. So first I need to import the global execution context so that some of these things that use futures can run properly. This get app is is what bootstraps the Play application, and you can see how we use that in the tutorial previous to this one, and it's linked below in the description. And then we get this course repo, which is just it's a service that I've made that wraps around this reactive Mongo library for Play, and it fetches courses for us from the database. After that, we create an instance here called start time that holds the current time in milliseconds on the machine, and log out that we're starting the performance test. At this point, I'm creating an array of 1 to 5 and just find all courses goes and gets every single course in the database, every single course and subject combination. Then we send that to so we do that 5 times, and then we run for each of those course combinations. We go and get the details of the course, which is this course repo find courses method here, and I'm passing it this course query here. Let's see, let's make this a little bit nicer to read. So the course query just takes a subject and a number, because a college course looks kind of like this, like Psychology 420 here. So anyway, so it's going to run that, and then for every single course, 5 times, it's going to go do an individual query to our Mongo database. So that should be, you know, a total. Let's run it real quick. Or sorry, I guess we'll go over that. We'll finish going over this. So all those course details are going to show up in this array here, course details. I think I'm going to do a tutorial on for comprehension, by the way, at some point. This construct here. But if you don't know it, check it out. It's a pretty cool concept in Scala. And then we calculate the end time minus the start time. Yeah, we print out some results here. Or we return the results. It says we found this many all course details. And we're logging out the size so that we can make sure that that's the same every time in our test, because it's very important that the test is deterministic, which means that it does the same thing every time you run it. And then the only thing that should change is the total time in milliseconds. Anyways, we wait for those results and then we print them out. And then we call system exit here so that SPT jumps out of the child process that runs this task. So let's go ahead and run our perf test here. So I'm going to go into an SPT console. So I'm going into the root project directory, typing SPT and clicking enter. It's got to load up some of the SPT configuration real quick. And here we are. Then we're going to type run main and then the object name of our perf test. So I'm going to copy the reference here, run it. There it goes. So it's running right now. It's got to start the play app. And now let's see where it's starting perf test right here. So right now it's doing all this work right here. And when it's done doing this work, we should see our message here printed out. Let's let this go. It should take about 20 seconds by my last test. Right, so let's go look and see the results. I have to scroll up because we see some things happening here. It had to close out. This system exit produces some log output. But if we check out before that debugging output, we can see that we found 18,235 courses, which is 5 times the number of courses we have in our application, in 28 seconds. So I want to run this again. And I want to see, we want to make sure that the seconds are like measurable. We want to measure basically the average of like 3 executions here, I think. So to run it again, I just went into the SPT console, hit up and enter, and that ran the previous command again. So we're running this test right now. If you guys like this content, by the way, I always appreciate it if you subscribe below. If you have any feedback or suggestions, it's awesome too to get comments about those. If you have any specific video requests, so far I made every single request. So if you want to request a video, I would love to make a video on any subject in the programming world for you, at least that I'm qualified to talk about. Okay, so let's take a look at these results of the test. Yeah, 26 seconds. Let's write these down really quick. Okay, first result, second result, and third result. So I'm going to run this again real quick while I write down the first result and the second result. Okay, so the first result is right here. The second result is right here. No, that can't be right. Was it exactly the same? No. I think we did. Here's the first result. So the first result took 28 26.124 seconds, and the second result took 26.199 seconds. We're still running our third perf test here, and that one took 32.111 milliseconds. Right, so now we're going to tweak our unit that's under test right now. So I think the easiest way to increase the performance, so we're not going to change anything in our test right now. All we're going to change is methods in our repos. So what I'm going to do specifically is add indexes on our Mongo collection that should hopefully speed up this find courses method here. So I'm going to go into here, and we just need to take a look and see how this is being used. So find courses is being used like this. So we pass it a query, a set of queries really, but we're only doing an individual query for each find courses call in this instance. And we create a query, a bson document, which is the Mongo, it's the markup that Mongo uses, with a subject of whatever our query.subject is and a number of our query.number. So that tells us that we need an index on subject and number. We need a combined index. So what we can do, I'm going to head over to the Mongo docs real quick. Mongo, and I think those are called compound index. Yeah. So we're going to create a compound index on our courses collection. It's called course here. So to do that, it's pretty simple. It looks like all we have to do is, let's find an example here. There we go. So all we need to do is run this create index function in our Mongo. So we need subject and number indexed together. So I am going to drop into the Mongo database real quick and just run this. This isn't the performance tweaking in Mongo specifically isn't really the scope of this video. What I really want to show you is how to performance test. So I want to see that I'm trying to do something that will increase the performance of our unit under test right now. So how I want to do this is create an index on subject and was it course or number? Subject and number. And that should do it. So now, if we look at our course, db.course, and I think it's get indexes. Yeah, we can see that our index exists right here. And now we've done nothing. We haven't changed our code at all. All we did was change the database indexes. We added an index, and let's see if we can beat our previous 3 times. I'm going back to the perf test because we marked down our times. So typically it was taking about 29 seconds on average. Let's do average results. And we can calculate the average by adding them all together and dividing them by 3. So 28124 plus 26199 plus 32111, and then we divide that by 3. So our average test took us this many milliseconds. It took us 28 seconds and 811 milliseconds. So our first performance test since we tweaked our queries returned in only 7,100 milliseconds. So we just made, and we're going to run it 3 more times so we get an average. So this is before adding index. And I'm just going to kind of duplicate the section and say after adding index, and then we'll get rid of these results here. Okay, so that ran the second time, and then we're going to run it one more time. Let's see here. So our second one's there. I'm trying to hunt down the results of these performance tests for us. Yeah, there's the, oh man, okay, it keeps moving because it's so fast. Okay, let's see, there we go. And I'm just making sure that, oh yeah, this is the one, that's what we want. Alright, so the first result of the, after adding the index was 7,100 milliseconds, which is a vast improvement. Looks like the third one's here. I missed the second one. The third one is right there, I think. Yeah, got it. Alright, so it looks like after we added the indexes, we still found the same. See how we found exactly 8,235 records each execution? That's important. It's important to make sure our jobs are deterministic. But in the third, or after we added the indexes, it took about a third of the time, maybe even a fourth of the time. We're going to find out exactly how much less time it took, I guess. 7193 plus 7756 plus 7199 divided by 3. And it took us 7,382 milliseconds on average versus 28,811 milliseconds before we added that index. So it was a tremendous improvement in our performance test there. So we can even say, percent decrease in execution time, and that would be, what is it? 28,811 minus 7,382, and then divided by the original amount, I think. Oh no, I think maybe it's like that actually. So if we take 7,382 and we subtract 28,811 divided by 28,811. Oops. This is our percent change right here. So we just made a 74% decrease in execution time for our task of running 5 times. So we definitely made things faster. Good job, guys. I think I'll probably go into more detail about tuning Mongo queries and indexes and things like that in another video. This is really just to show you guys how to write a simple perf test. Thanks for watching, guys. If you liked it, as always, please click the subscribe. Comment below to leave me some feedback. Share this stuff with your friends, guys. It's always awesome. Any of the code you see on this is yours to use and distribute as you see fit. So thanks again for watching, guys, and until next time, have a nice day.